Hello guys, welcome to Easy Learning, and in this tutorial we want to continue with the structure of an atom, and this is our lesson 3. So we will talk about the electronic configuration, we'll talk about valency, and we also talk about ion. Then we end the lesson. So let's quickly begin with electronic configuration. Electronic configuration. So what is electronic configuration? It is simply the arrangement. Electronic configuration is simply the arrangement of electrons. It is simply the arrangement of electrons in the shell of an atom. As we move forward, I will explain this definition. So electronic configuration is the arrangement of electrons in the shell of an atom. And at the GHS level, we mostly deal with 4 shells: the K shell, L shell, M and N. And we have a formula 2n squared. So this is the formula that we use to determine the maximum number of electrons that each shell can hold. The K shell has a value of 1, L has a value of 2, M has a value of 3, and the N has a value of 4. So whenever you see N, you insert that value to know the maximum number of electrons that each cell can hold. So K is 1. So you solve this one first. 1 squared is 1. So 2 times 1 will give you 2. So the K cell takes a maximum of 2 electrons. You insert 2 here. 2 squared will give you 4. So 4 times 2 will be 8. The L shell takes a maximum of 8. We have 3 here. 3 squared is 9 times 2, 18. 18. So the M shell takes a maximum of 18 electrons. And the N, the value of N is 4. So 4 squared is 16 times 2, 32. So the N takes a maximum of 32 electrons. So these are the maximum number of electrons that each cell can hold. But per the octet rule, we are following the octet rule. The octet rule, which states that the M and the N should both take maximum of 8 electrons. So per the octet rule, the M and the N shells will take 8 electrons each. So let's see how you can arrange electrons inside the shells of an atom. Let's consider the carbon atom. It has 6 electrons. This is the nucleus. This is the K shell. So the K shell takes a maximum of 2 electrons. And the remaining 4 electrons, you put it inside the N shell, the L shell, sorry. So arranging these 6 electrons inside the shells of the carbon atom is what is called the electronic configuration. Whenever you are arranging electrons inside the shells of an atom, we call it electronic configuration. So let's see how you can write the electronic configuration for various elements. We should know this before you can write electronic configuration. So let us write the electronic configuration for potassium. The case takes a maximum of 2 electrons. We now have 17 electrons left. The L takes a maximum of 8. So 10 electrons have been consumed. We now have 7 electrons left. We now have 9 electrons left. The M shell takes a maximum of 8. We now have 1 electron left. And we put that 1 electron inside the N shell. So the electronic configuration for potassium is 2, 8, 8, 1. So in exam, this is how you write the electronic configuration: 28H1 for potassium. Let us move to other atoms. Let's consider the sulfur atom with atomic number 16. K shell will take 2, remaining 14. So 14 electrons are left. The L shell takes a maximum of 8. So 10 have been consumed, remaining 6 electrons. The M shell takes a maximum of 8. but now we now have 6 electrons left. So insert the 6 electrons into the M shell. This is how to write electronic configuration. Let us consider one last example, and that should be sodium, atomic number 11. K takes 2, 8, 1. And this is how to write electronic configuration. So let us quickly move to valency. 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 Let us quickly move to valency. So what is valency? Valency is simply the combining power of an element. Valency is simply the combining power. The combining power of an element. Valency is simply the combining power of an element. So how do you determine the valency of an element? So let's take note of this. Whenever you write the electronic configuration, for any element, let's say potassium, electronic configuration for potassium is 28H1. So when you write this electronic configuration, so whenever you write the electronic configuration and the valence electron of the element is 1, 2, 3, or 4, that automatically becomes the valency of that element. So over here, the valence electron for potassium is 1. So automatically, the valency of potassium is 1. Magnesium, electronic configuration is 282. Because the valence electron of magnesium is 2, the valency of magnesium also becomes 2. The valency of magnesium also becomes 2. Carbon, or let's say boron, atomic number 5. Because the valence electron of boron is 3, the valency of boron becomes 3. So that is that. But in case the valence electron of the element, is 5, 6, or 7. To know the valency, you subtract it from 8. Let's see what I mean. Sulfur, 286. The valence electron of sulfur is 6. Leave the K shell, L shell, M shell. M shell takes a maximum of 8. By here, it is taking 6 electrons. So it means that it needs 2 extra electrons to become 8. So it needs 2 electrons to become 8. Therefore, the valency of sulfur is 8. That's why I'm saying that when the valence electron is 5, 6, or 7, to determine the valency, subtract that valence electron from 8. So over here, for sulfur, the valence electron is 6. Subtract it from 8, you get 2. So the valency of sulfur is 2. Let's consider chlorine, atomic number 17, 287. Because the valence electron of chlorine is 7, you have to subtract it from 8. So 8 minus 7, you get 1. So the valency of chlorine is 7. The valency of chlorine is 1. 8 minus 7, you get 1. So the valency of chlorine is 1. Let us consider other examples as well. Let us consider oxygen. I hope you can see my handwriting. Let us consider oxygen. Atomic number 8. The valence electron for oxygen is 6. So we subtract 6 from 8. So the valency of oxygen now becomes 2. The valency of oxygen now becomes 2. Let us consider nitrogen. Nitrogen. Atomic number 7. When we add the electronic configuration, the valence electron for nitrogen is 5. You subtract 5 from 8 and you get 3. Therefore, the valency of nitrogen is 3. So that is all about valency. Let us quickly move to ion. An ion is an electrically charged atom. An ion is an electrically charged atom. So we have an atom, and anytime the atom loses electron, it will become an ion. Or if you have an atom and the atom gains electron, it also becomes an ion. So let's see how will you know whether the atom will lose electron in order to become an ion, or whether the atom will gain electron in order to become an ion? It's all about the valency, or it's all about the valence electron. If you want to know whether an atom will lose electron or gain electron in order to become an ion, it's all about the valence electron. So let's see, when the valence electron is 1, 2, or 3, it means that for that element, it will lose an electron before it will become an ion. And anytime when an atom loses electron to form an ion, when an atom loses electron, it forms a cation. A cation is simply a positively charged atom, or an atom that has a positive charge. So let's say X is an atom, then it loses electron, it will become a cation. It will gain a positive charge on it. So anytime that an atom loses electrons, it forms a cation. And anytime that an atom gains an electron, when an atom gains an electron, anytime an atom gains electron, it also forms an anion. That is a negatively charged ion. So when you have an atom Y, and that atom Y receives an electron, it will form a negatively charged ion. So a negatively charged ion is called an anion, and a positively charged ion is called a cation. So anytime that you have the valence electron of an element or of an atom to be 1, 2, or 3, it means that element is going to lose an electron before it forms an ion. Let us consider example, aluminium. The valence electron of aluminium is 3. So it means that for aluminium to form an ion, it has to lose 3 electrons. Whenever it loses electron, it will be a cation. How many electrons did it lose? It lost 3, so Al3 plus. When aluminium forms an ion, this is the ion that it will form, Al3 plus. Magnesium. Magnesium has a valence electron of 2. So when magnesium forms an ion, what will that ion be? This is it. Because the valence electron is 2, it means that it will lose 3 electrons to form an ion. Because it lost 2 electrons, because it lost electrons, it will be positive, and the electrons that it lost is 2, so 2 plus, Mg2 plus. Let's consider sodium. Because the valence electron is 1, it is going to lose electron to form an ion. So whenever it loses electron, it is positive. How many electrons did it lose? 1. So because it is 1 plus, you will not write the 1, you just write plus. The same as lithium, Li plus. The same as potassium, A plus. Because when you add the electronic config, this is atomic number 3. So the valence electron is 1. Sorry. This is atomic number 19. So the valence electron is 1. So this is the ionic state of potassium and lithium. So let us consider the other case. The other case so if you also want to know, this is the case for cations. So let's see for the case of anions. How will you know whether an atom will receive electron to become an ion? So when the valence electron is 5, 6, or 7, it means that atom will receive or will gain, let me use the word gain, it will gain an electron to form an ion. And that ion will be an anion because it will be a negatively charged ion. Let us consider examples. Chlorine, atomic number 17. The valence electron for chlorine is 7. So for chlorine, it will gain electron to form an ion. So when it gains, it becomes negatively charged. How many electrons will it receive? So how will you know? This is the M shell. M shell should take a maximum of 8. But over here it is taking 7. So how many electrons does it need in order to become full? It needs 1. Because it is 1, you will not write the 1. So it will be Cl minus. That is the ionic state of chlorine. What about sulfur? Atomic number 16. 286. So when the valence electron is 6, it means it will be an ion. It will receive an electron to form an ion. So an anion. So negatively charged ion. The K shell, L shell, and the M shell. M shell takes a maximum of 8. Over here it is taking 6. So it needs extra 2 to become 8. So 2 minus chlorine, sulfur. Let me consider oxygen. Oxygen, atomic number 8. K shell, L shell. Because the valence electron is 6, it means it is going to receive. When it receives, it becomes a negative charge. The L shell takes a maximum of 8, but now it is taking 6, so it needs extra 2 to become 4, to become 8. So you put a 2 there. So this is the ionic state of oxygen. So that is that. So we have discussed electronic configuration, how to determine valency, and we have now discussed ions. So this is an ion. A negatively charged ion is called an anion, and a positively charged ion is called a cation. So this brings us to the end of our lesson. So please don't forget to like this video and also share the video. Please share the video. And if you have not subscribed to the channel, please do well to subscribe. See you in another lesson.